Hello guys, welcome to the stream. Sorry for being late because I am busy in some work. So sorry for that. अब आ रहा है. So today I studied that topological sort and also the Khan algorithm. So let me revise it, then maybe I will explain you that what actually it is. So wait a moment. Mhm. Topological sorting. Okay. सो जीरो को डायरेक्ट नहीं बोल सकते. अभी जो स्पीड डिपेंडेंट है वो पहले जाएंगे और तभी सही ऑर्डर प्रिंट होगा. Detect cyclic. Okay. DFS fine topo short. DFS topo. I will call it again and again. Yeah. Fine. Hmm. Keep going. Thank you, buddy. Uh, Thank you. So let's start. Uh, that what is topological sort? Okay. So first I have to understand the definition that what is topological sort is. So wait. I know that how we can perform it, but I don't know what actually a topological sort is. That why we use it. Okay. So what is topo short and why we use it? Hmm. Why we use it? Topological sort is linear orbiting vertices in a directed is a place of the every directed is from U to V from before node. Think of it as a sequence task where certain tasks must be completed before other tasks. Two identical constraint of Coco it is a directed graph. Why do we use it? When you need to solve dependency resolution problems, if something converges to building system packages it will depend on take also figure out install first. So it is a linear ordering vertices. It directed edge. So what I understand from the definition is that what is topological chart? Basically, it is a linear ordering. So what is linear ordering means? Suppose if there is a node 1, okay. So wait, if there is a node 4 and we'll see, oh, what the hell? We'll see. Wait, what? Now wait. Do see control V. If I copy it down, control C, control V, control C, control V. Okay. So there is 4 and 5, and then 1, there's 2, and there is 3. Okay. And okay, so topological sort will be applied on direct acyclic graph. Okay. So there are two type of graph that पांच अबे ये कौन है ये चाय समोसा कौन है Okay, bhai. So listen. So there are two types of graph. Like if we consider that there is a loop or not, which is one is the cyclic and another one is the acyclic graph. So if we consider this, let's suppose there are four nodes. Oh, wait. V control C V control C V. Okay. So if you see here that here the cycle will be created, but is this actually a cyclic graph or not? So basically, what is the difference between a cyclic graph is that in a graph there is a loop will form. So it means that if I started from this node, if I again after traversing over whole graph, if I reach again at this node, then it means that this is a cyclic graph. And if I never reach there, it means that this is acyclic graph. So if you see this, if I again wait, mm, wait. Hmm. Just wait. नो लूप सर भाई देखो तुम्हारा जो भी नाम है ठीक है अगर पढ़ना है तो तमीज से पढ़ो और नहीं पढ़ना तो भाई निकल लो यहाँ से ठीक है अनुराग भाई आई एम सॉरी बिगिनियर आई नो जावा एंड वांट टू स्टार्ट कहाँ से करूँ बेस्ट चैनल अरे भाई उससे कोई फर्क नहीं पड़ता भाई डेटा स्ट्रक्चर तुम कहीं से भी पढ़ सकते हो अगर तुम्हें लैंग्वेज की नॉलेज है तो तुम तो कर सकते हो ना उससे कोई फर्क नहीं पड़ता लैंग्वेज वैंग्वेज से कोई फर्क नहीं पड़ेगा डेटा स्ट्रक्चर पे और मैं तुम्हें लॉजिक समझा रहा हूँ इसमें लैंग्वेज का क्या लेना देना है एरे जावा में भी होगा तो एक एरे का एक कोई क्वेश्चन होगा कि हाँ भाई मुझे टू सम निकालना है तो टू सम में निकालने के लिए क्या करते हैं दो लूप चलाएंगे और दो एलिमेंट्स लेंगे और उनका चेक कर लेंगे कि ये सम बराबर है तो इसमें लैंग्वेज से कोई लेना देना ही नहीं है तो लैंग्वेज डिपेंडेंट थोड़ी है डीएसए तो कोई भी लैंग्वेज से कर सकते हो बट ये है कि मोस्टली प्रेफर करते हैं जावा सी प्लस प्लस तो उसमें से अगर कोई भी कर रहे हो तो चलेगा इट्स फाइन so if you see in this both graph that suppose if I wait so if you start from this point okay and if I traverse over a graph that from this point I can jump up to this node and then from this node I will jump up to this node भाई तुम नाराज हो गए नाराज होने की बात नहीं है यार तुम जैसे लोग ही हैं ये देश को बर्बाद करने के पीछे जब करियर बनाना होता है तो टाइम पास करते हैं और फिर लंका लग जाती है अपनी so if you are on this point you can move up to this point and then if you reach there again it means that there is a loop so this is called a cyclic graph and if you see here if I start from this point I can never reach on this point again so this is called an acyclic graph okay so that is the difference between the cyclic and an acyclic graph हम्म अरे ये चाय समोसा पता नहीं क्या क्या तो नाम रख के आ गए हैं भाई क्या बदतमीजी है पता नहीं तो मैं नहीं बोल रहा भाई तो मैं तो वो चीज बोल रहा हूँ कि किसी भी लैंग्वेज में कर सकते हो उसमें कोई इश्यू नहीं है so this is the difference between the acyclic and cyclic graph so the topological sort will be perform in an acyclic directed graph. So you know that what is the directed graph is. In a directed graph, from one node we can jump up to another node. That there is no way to track back. Like if I reach from 4 to 5, if there is no point which is pointing towards 4 again from 5, it means that this there is no way to reach the 4 again. So if you see that if this arrow is used, it is called a directed arrow, or it point that this is a directed graph. And if I use this single line, this is called a directed graph. So that is the difference between this directed and a directed graph. Oh, sorry, a directed, no, not a directed, it's undirected graph. Sorry. So we will perform that operation, that how we know that what how we can traverse over an array. Sorry, not array. We can how we can traverse over a graph and write that what is the topological sort. So what is the topological sort? Topological sort is a writing all the graph elements in a linear way so that one node comes after the other. Like suppose if I traversing over this graph, then if I write 2 and 1, this is not possible because here we will see that 2 will come after 1, not before 1. Okay. So what happen is, so this is not considered to be a topological sort. Okay, so how we can perform it? So if I perform a topological sort, then the second question is where it is used. So it will used when some task will perform sequentially. So suppose what I want is that I want to open some game. Okay, so there is a main folder. Okay, and inside that main folder, there is some other folder. So main folder and then some other folder. Suppose there is a folder called uh, FIFA setup. Okay, and inside that there is another folder which is called FIFA.exe. So if I want to open this game, first I have to perform this operation, and when this folder will open, after that this will be open. FIFA setup. And after this FIFA setup is opened, then after that I can open that game. It means that this will be this all task will perform in a sequential manner. I cannot do like that I can open FIFA setup first and then I will open that main folder. So if there is a sequence of operation that is required to perform, at that point we need that what is the sequential manner that we need. Okay, so for that, we can use the topological sort. So here it is given that, okay, there are five operations, 4, 5, 1, 2, 3. And if I have to perform all operations, what I want is I want to perform firstly the fourth operation, and then fifth operation, then second one, then first one, sorry, then first one, then second one, then third one. So let's consider it to be a zeroth operation. This is one earth operation, and this is two earth operation. Now what we see is that, okay, first we have to connect this. Hmm, Control C and V. What the hell? Control C. Okay. So here you will see that, okay, 0 is connected with 1, 1 is connected with 2. Now if we perform the operation, it will be start from which position? So it will be start from this 0. So how it will be printed? So first 0 is printed, then 1 is printed, and then 2 is printed. So after that, when 2 is finished, there is no other node. So what happen is, then we will again start a loop and we will check that what all nodes are not visited. So we will see that, okay, 4 and 5 is not visited. So I can start it from 4. And after that, I will print 4 here. And after that, I will print 5 here. So this is how, when we actually perform any traversal like BFS or DFS, we will see that this is how actually our nodes will print it. But how actually I want to print it? I want to print it in form of 4, 5, 0, 1, and 2, right? So this is a topo shot that first 4 is printed, then 5, then 0, then 1 and 2. So this is how it actually printed. So what we will do? So one thing we observed that, okay, what we want is we want to print that 0, 1, and 2. Initially, what we want, I want to print that 0 and then 1 and then 2. And this 4 is and 5 will not print it after 2. What I want is if somehow it will be printed before 0. So this order is correct, right? So what I want is I want to print that 4 and 5 before. So this order is correct now. So what we know is okay, okay. So how this will perform? How this will perform? So we will, okay. So initially, first this, if we see from last, wait, I have to copy this. Mm, mm, mm. So if we see the printing operation 4, 5, 0, 1, sorry, 0, 1, and 2. Okay. So what I want is that I want to print it in form of this, and I know that it can be start from 0. Fine. So I know that I will start it from 0. Wait. Hmm. Okay, it will be start from 0. Now, if I perform a DFS traversal, okay, if I perform a DFS traversal, what I want is I want to print whatever come in a last. So if we see it from last node, what I want is I want first I want to print. Okay, so there is 0. So I will see that okay, there is 0, and I know, and let's perform the operation. So I will create a visited array. One thing I also observe is that first I will print 2, because if we see from last value, what I've seen here is okay, I will start it from 0. But if we see this sorting order, first the 2 is printed, then 1 is printed, then 0 is printed. And then after that, whatever the element that is left, I will reach there, and then I will jump till the node which is not visited. Sorry, I will jump till the node which is visited. Like I will see, okay, 4 is not visited, 5 is not visited, and then I will see, okay, 0 is visited previously. That's why I can print 2, 1, and 0. Okay. And after that, I will see, okay, there is 5 present which is not visited. So I will print 5 first, and then when I track back, I will print 4. So let's see how it actually performs. So when I am on 0, I will mark it that what all nodes are visited 0, 1, 2, 3, 4, 5. Uh, will it require 5, 1, 2, 3? Okay, so I have to write 3 here. And I have to, or will I will add one more node. That okay, this will be 4. Control CV, and this will be 3. Which problem are you solving? Okay, actually I'm revising topological sort, buddy. That how we can perform a topological sort. So I will understand it little bit, and I will try to explain that will I really understand it or not. So okay, till now what we analyze is okay, that if we see this sorting order, what I want is whatever the element, because I know that I can start it from 0 position, and then I will jump up to some point. I will, And when I jump up to the last, and I will see whatever the last element that is present, I will print it. After that, the second last, and then this one, and then this one. And now, when I reach up to this 0 point again, now till that point, all nodes are visited. So after that, I will check that what all nodes are not visited. Okay, are you doing DFS topo shot now? Trying to cover BFS method too. Khan algorithm. Okay, okay. I will try. I will try. I will try. So, uh, what we have to do is, okay, I will check, okay, what all nodes are not visited. So 4 and 5 is not visited. So I will see, okay, that 4 is not visited. I will jump onto the 5, that, okay, I already visited 4, and then jump up to 5. I will tell that, okay, I already visited 5, and then I jump up to 0. So when I jump up to 0, before jumping, I will see that, okay, 0 is already visited previously. So I will see, okay, yeah, it is visited. So I will track back. Before tracking back, I will just print 5 value here, and then 4, and then track it back, so that loop is over. So this is what we have to do. So when I am on 0, what I will do is, okay, what I will do is, okay, I will mark that, okay, I will visited 0. And after that, I will jump up to 1. Oh, wait. What the hell is going on? Select the pencil. So wait, will I push it back or do something else? Okay. So I will jump up to 1. So, okay, jump up to 1. If this is not visited, I will check if this is visited or not. So this is not visited. I will mark it as now I will visit 1, and then jump up to 2 here. Okay. So jump up to 2 here, and then I will mark that, okay, 2 is also visited. So I will mark that 2 is visited. Wait, 2 is visited. Then I will jump up to 3 here. Okay, 3 is there. And okay, 3 is there. And when I reach up to 3, I will see that is there any node that is left after 3? So no, there is no node. So 3 is the last node. So if 3 is the last node, what I want is I want to print 3, 2, 1, and 0. So when I track back, what I want is I want to store that what are the last element that I stored. Because what I want is that whatever the element that is stored in last will be pushed first in an array. Okay, so if I want to print all the element in a sorted order, I have to store it somewhere. So I will store it inside array. So what I will do is that, okay, so if I see that, okay, 0 is there, 1 is there, 2 is there, and 3 is there. So when I visited last node, what I will do is I will create a stack and store that, okay, I already visited 3. When I jump up to 2, okay, I will tell that, okay, I visited 2. So now, as I tracking it back, I will store it. Now, okay, okay, okay. ठीक है, ठीक है. Hmm. So when I see here, okay, two is there, and after that, when I track it back, and I will see, okay, 1 is there, and I already visited 1, so I will put it inside the stack. Okay. And when I jump up to this position, I will see, okay, I already visited each and every node, and I am on starting node. भाई मिलता हूँ तुमसे कॉलेज में. भाई मैं कॉलेज ही नहीं आता हूँ. आह, नाम तो बताते जाओ. नाम बताते जाओ. तो ये है कि भाई मौज मस्ती अपनी जगह है, लेकिन अभी थोड़ा सीरियस माहौल है. फोर्थ ईयर में चल रहे हैं भाई, प्लेसमेंट का टाइम है. अभी लगेगी नहीं तो लंका लग जाएगी अभी पूरी. वही बात है. So there is 0, and as I already visited this 0, I will print it. So I will store it inside the stack, right? So I will store 0, and now after that this loop is getting finished. So I will see that what all elements I will be present here. So I will see that okay, 0 is there, 1 is there, 2 is there, and 3 is there. So this is all element that is present, and after that I will check that what all nodes that is not visited. So the nodes that is not visited here is 4 and 5. Okay, so I will reach up to 4 and I will see, okay, 4 is not visited. So currently I will mark that, okay, now 4 is visited. So I also mark 3 is visited and then 4 is visited. Now I will see that, okay, 4 is visited. I will jump up to 5. I will jump up to 5 and then, okay, I will see the, okay, 5 is also not visited. So I will mark it that, okay, now I visited 5. Now after that, when I jump on 0, I will see that okay, this is already visited. So so if this is already visited, what I will do is I will track back. So when I track back, what happen is when I track back, wait, when I track back, what happen is okay, I will store that 5 inside the stack. So I will store 5, and now I will jump up to 4 here. Now I will see that okay, 4 is already visited, and as I was tracking it back, I will store the 4 inside the stack. So now 3, 2, 1, 0, 5, and 4 will be stored inside the stack. And after storing it, as I will see that, okay, all nodes are visited. After that, whatever the element that is present inside the stack, I will print it inside an array, or I will store it inside an array. So what I will see is that if I popped out all the elements from stack till the stack is not empty, this will be stored in this form 4, 5, 0, 1, 2, and 3. So this is what order that we actually want, and this is called a topological sort. जब कभी मिलेंगे तो देखा जाएगा. बढ़िया बंदे हो तुम. थैंक्स बडी. थैंक्स. डोंट माइंड, लेकिन अभी मेरा दिमाग थोड़ा ज्यादा खराब है इन सब चीजों को लेके, तो मैं थोड़ा सा सीरियस हूँ इस चीज को लेके. तो कोई भी मजाक वगैरह कर रहा है तो भाई गुस्सा आ जा रहा है मुझे इस चीज को लेके, सॉरी. अभी जस्ट यूट्यूब खोला, देखा तुम ऑनलाइन हो तो सोचा थोड़ा तुम टांग खींचते कर दूं अपने दोस्त को. अरे ना, अरे अगर भाई मेरे जान पहचान में हो तो मेरे को मैसेज कर दो ना, तो मेरे को पता तो चलेगा कौन है. वरना मुझे कभी कभी, क्योंकि यूट्यूब पे स्पैमर्स भी होते हैं ना. लंच साथ करते थे. आई विल थिंक. कौन है? ललाट. नहीं, वो कोई दिक्कत नहीं है. मतलब वही है कि थोड़ा रेज हो जाता है. यहाँ पे स्पैमर्स भी आते हैं ना बहुत सारे परेशान करने. तो इसी वजह से मैंने बोल दिया. मुझे लगा कोई स्पैमर है, और नाम भी ऐसा ही है, चाय समोसा. तो इससे मुझे क्या पता चलेगा. हम्म. हाँ, सामने मिलूंगा तो हिंट दूंगा, समझ जाना. अरे मैसेज कर दो भाई. इतना पढ़ते मैं, क्योंकि कॉलेज नहीं आने वाला है, पता नहीं कब आऊंगा. और जब आऊं तो पता चले प्रैक्टिकल उसमें आऊंगा, प्रोजेक्ट वगैरह में, तो पता चले सबका अलग अलग हो तो तुम आओ नहीं. वो भी हो सकता है. So this is what the topological sort is, and okay. Now what we see here is okay. We have to. मैं खुद नहीं आता. यही बात है ना. तो तुमने ट्रेनिंग ज्वाइन नहीं करी है? हम्म. ओके ओके ओके. ओके ओके. गुड बाय बडी, गुड बाय. सो ओके, मैं ये तो समझ गया कि how we will perform that topological sort, and what we also understand is that we need a data structure called stack. And what we also have to do is first we will reach up to the last element, and when I reach up to the last element, then when I track back, at that time I will store that particular element inside a stack. Okay. So this is what we have to do. Okay, fine. So basically we have to perform a DFS. Okay. So let's try to code that what we have to do. Okay. So what I want is that suppose if I write topo topo shot, we have to perform topo shot, na? So there are some vertices, okay, that is given. So if some vertices is given, and vertices will represent that how many vertices I have. I have 1, 2, 3, 4, 5, and 6. So this all are the 6 vertices. So I will create a vector visited, which tells that if this node is visit or not. So I will mark it that okay, initially the vector visited will be of v size, and initially all values will be false because I never visited any node. After that, I will create a stack, and inside that stack, now I have to perform the operation. So what I know is I already seen that I can start it from zero, right? And as I started from zero, what I've seen here is from zero, I can reach up to three. And after that, after three, the node is getting finished. But I will left with four and five. So what I have to do is for 4 and 5, I have to again perform that same operation. Okay. So as I want to perform that operation on all vertices or all nodes, so for that, what I will do will I will run the loop vertex number of time that so that all the vertices will be checked. Okay. So it means that I have to run a loop, and what I will do, I will write the V here that I have to visit all the nodes. After that, I will check if this node is visited or not. So I will say, okay, if this is visited, so visited, I will create a visited array, which will tell me that if this node is visited or not. If this is not visited, what I will do is I'll perform the DFS topo, topo. And inside that, what I will do is that I have to pass that particular node. So what is the node? That this is the adjacency list. And now this is the adjacency list, and I have to tell that okay, I will okay, I think so this will be correct. But when I do something wrong in code, Khan algorithm topo shot, I think so I'm doing right. I will pass that what okay. So rather than passing, okay, I know that this is the particular this is the particular node that I have to visit. So it means that I have to write here whatever the I is, and then I will pass one thing that is called stack, and then I will pass what? I will pass that if this node is visited or not. Visited, visited or not. So it means that now I will perform here that void and void void DFS topo. DFS topo, and inside it I will pass that okay, this is the node, and then there is a vector vector int, and then visited, and there is stack. Wait, this is a stack in st. Okay, and now what I have to do that in a DFS traverser, what we will do, we will tell that okay, this is the node now, so I already visited it. Okay, fine. As I already visited it, I will mark it as true that this node is already visited. After that, I will check all the nodes that is connected with this node. So how will I check it? As I want to check it, uh, I will perform this int x, and then whatever the adjacency list, and in adjacency list, all the node I will check that what all nodes are connected with this node. So I will check, okay, this all nodes are present here. So I will check, okay, if this node is visited or not. Okay, so I will see, okay, if this is visited or not. If this is not visited, okay, wait. Mm, I will check that if this particular. So what we see here is, okay, when I am 0, I will check that, okay, 1 is visited or not. So if 1 is not visited, I will jump up to 1 and I will mark that as that this 1 is visited, and then I will again perform that same operation DFS topo, right? So inside here, I will pass that, okay, X. If this is not visited, then what I will do is I will mark that, okay, visited X to be, wait, visited X to be true. And inside this, I will again perform that same operation DFS topo. And inside that, I have to pass what, how many things? I have to pass this X that, okay, I have to visit this node. And then I will again pass this visited. And then again, I will pass this DST, whatever the stack is. And when I backtrack, it means that when I reach up to last node, okay, and when I reach up to last node and I will see, okay, after that there is no other node that is present, so I will track back again. So it means that when I tracking back, I reach up to 3, I will see that, okay, this is visited. As this is visited, and when I come out from this node, what I will do is I will just push whatever the node is. That, okay, after performing the DFS traversal, what I know is that anyhow I will run, sorry, when I perform the DFS traversal, what I will know is anyhow I will jump up to this point. So after this point, there is no node. So I will see that, okay, this is the last node. So if this is the last node, then this for loop will get finished. So when this for loop is getting finished and when I am on last node, what I want? I want to store that 3 inside the stack, right? So how will I know that this is 3? So what recursion will do? Inside recursion, we will pass what is the current element. So basically, this node will will contain what is my current element. So if I am standing on 3, what is my current element? 3. So what I will do, I will push that element inside a stack, right? So I will push that, okay, stack dot push, and inside that I will push whatever the node I have. So this is it. So this is, oh wait, mm, okay, mm, visited, and then there it's stack. Okay, this is it. And now after that, I will create a vector and answer. Okay, and then I will start a for loop. Oh, wait, for loop in, no, 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 not for loop. While st dot till the stack is not getting empty, what I will do, I will store all the elements that I have, st dot top, and then st dot pop. So this is all about the topo short, topological short. Have you understand that what is this? Maybe. So this is the topological short, and this will be performed using a DFS traversal. Okay. And now I will left with performing that shorting algorithm using BFS traversal. And that algorithm is called as scan algorithm. So first I will understand that what we do in this algorithm. Which you execute you किसी को depend नहीं है तो पहले क्लास को इंटीग्रली फाइंड करो तो किसकी पर जो है बाकी से कनेक्टेड है इनको पुश करेंगे कर दूंगा क्यू में इन उसकी इंडिविजुअल एक कौन सा है find in degree of order push 0 in degree vertices into Q and pop element from Q. If neighbors in degree 1 so degree 0 in degree never push into Q. Okay, so how I will think that, okay, this is how we can do it. Mm, Let me think. Let me think. What I will think. Hmm. I have to observe something. So if I create some other graph, let me create another graph. And then we observe something. Let's see, this is mm, chart. Okay. Mm, then there is another point, and there is another point. Mm, So this is 0, and this is 1, 2, no, this is 0, this is 2, this is 3, this is 4, this is 5, and this is 6. Okay. So in where the topological sort is used, so topological sort is used to print or to perform something in a sequential manner. That if I want to perform something and I want to know that what all are the sequences, okay, so that is where that is the point where topological sort is used. So if you see here that okay, I know that I will start it from 0, right? So if I perform the DFS traversal, what we will do that if I standing on this point, I will okay, 4, 5, and wait, I have to remove this. So basically this is it, and I have to remove this. Okay, so if I perform a DFS traversal, what I will know is that I can start it from 0 point and I jump up to this one, and then I will see, okay, jump up to 3 and then 4. Okay, now there is another DFS traversal is that if I started from 0, I can jump up to 2. Okay, so it means that maybe it will be printed in form of first I will print that, okay, if I started from 0, okay, and then 2 is printed, or maybe yeah, then 2 is printed, and then 1, and then 3, and then 4, and after that whatever the nodes that is left, that is 5 and 6, 5 and 6, this will be printed. So maybe this will be the order, or if if I assume that any other order, so it will be 0, and then 1 and 3 and 4, and after that with 0 the 2 is linked up, and then all the left node, that is 5 and 6, so this is printed. So if you see this order, if you see this order, what we will see? We will see that before that we have to note two more concept that what is in order. Sorry, or in order or something else. Wait, what we call this? We will called it, I think so, in order, no? Sorry, in degree. So in degree or out degree. So what is in degree? That how many nodes are pointing to a particular node, or how many n- arrows come towards a particular node will tell that what is the in degree of that particular node. So what I will see is, okay, z on 2 there is only one node is pointing, that is 0, and after that on 1 there is one node is pointing, that is 1. On 3 the one node is pointing, that is 3. Okay, and on 4 there are two nodes is pointing, that is 3 and 5. And on 5 there is no node pointing, so this is 5. And after that on 6 there is no node, sorry, so there is only one node is pointing, that is 5. And on 3 there are totally two nodes is pointing, that is 1 and 6. Okay, okay. So uh okay. So what we will think here? What is this a correct topological order or not? So this is not the correct topological order. So what is the correct topological order? So the correct topological order is, I have to remove this. This is not the correct topological order. So the correct topological order is all the, so first I will start it from 5. Okay. And then I will print 6. And after 6 the 2 is printed, and then 0, 1, 3 and 4. So this is the sequence. So if we, okay, so let's understand it again. So just remove this. This is 4 here, this is 5 here, and this is 6 here, right? So in a DFS traversal, what we have studied, that okay, I will start it from 0 and I will perform the DFS traversal. So if I perform the DFS traversal, it will move towards the uh, end. That if there are many paths, it will select only one path and go on that path till we not reach the end point. So if I will start it from 0, I have two paths, that I will start it from 0 and I will go towards 2, or maybe I will go towards 1. So suppose if I go towards 1, so this one, no, wait, uh, okay. So what I've seen here is, okay, I can start it from 0 and jump to 1, and now I will jump to 3 and I will jump to 4. Okay, and basically, wait a moment, I have to remove this. So, oh, wait, what the hell? Hmm, I'll remove this. I will remove this. Okay, so okay, I will see that I will start it from 0, I will jump up to 1, then 3, and then 4. And when I jump up to 4, I will see that after that there is no node. So when I track back, what I will do is I will create a stack, right? So I will create a stack. Bro, can you suggest me the best way to start the DSA? I am literally confused from where to start. Okay, so if you want to start, तो भाई ऐसा करो कि बिल्कुल तुम्हें बेसिक्स आते हैं कि बेसिक्स भी नहीं आते? सो व्हाट आई विल डू इज व्हेन आई ट्रैक बैक, ये बता दो मेरे को बेसिक्स आते हैं कि नहीं, उसके हिसाब से मैं बताता हूँ फिर. सो आई विल स्टोर 4 here and then I will track back. When I track back, पाइथन बेसिक्स, पाइथन बेसिक्स, मेरे को बस एक चीज और बता दो कि क्या तुम्हें इसका इंजीनियर, सॉफ्टवेयर इंजीनियर बनना है या एमएल साइड जाना है? क्योंकि जो मेरे मेरे को जहां तक इतना पता है कि भाई अगर तुम्हें करनी है डीएसए तो सी प्लस प्लस या जावा में करो. ठीक है, तो ठीक है, तुम्हें पाइथन उसके बेसिक्स आते हैं डीएसए के, तो तुम ये कर सकते हो कि इफ यू आर प्योर बिगिनियर, देन तुम क्या करो कि कोई भी एक जगह से, चाहे तो अगर मान लो तुम्हें इंग्लिश में समझ में आता है तो स्ट्राइवर, या हिंदी में समझ में आता है तो कोडर आर्मी, यही दो लोग हैं. ठीक है, एआईएमएल इंजीनियर बनना है. ओके, हाँ, तो फिर डीएसए तो तब भी तुम्हें करना ही पड़ेगा. तो वो वाली चीज है कि इन दोनों में से किसी का भी एक बार कोर्स उठा लो. ठीक है, और तुम इनका कोर्स कंप्लीट करो जितनी जल्दी पॉसिबल हो सके. 2 महीने में खत्म हो जाए लेक्चर देके, 2 महीने में निपटा दो. उसके बाद तुम प्रैक्टिस करना चालू करना. तो पहले तुम्हारा ये होना चाहिए कि उन लेक्चर्स में जितने क्वेश्चन कराए गए उनको समझ के 4 बार 5 बार जितनी बार करा जा सके करो. और अगर तुम्हारे पास ज्यादा टाइम है, ठीक है, तो ज्यादा टाइम है तो आई विल सजेस्ट कि तुम क्या कर सकते हो कि जेमिनाई या जीपीटी कुछ भी खोल लेना, या डीप सीक वगैरह जो भी चीजें हैं. ठीक है, तो वहां पे जाना और उसको डाल देना, आई वॉन्ट टू ज्वाइन सम कंपनी. तो मान लो कि जो भी तुम्हें कंपनी ज्वाइन करनी होगी उस कंपनी का नाम डाल देना. एंड आई वांट टू मास्टर डीएसए इन, जितना भी मंथ है तुम्हारे पास वो मंथ बता देना उसको. मास्टर डीएसए इन 8 मंथ, सपोज तुम्हारे पास 8 मंथ है. प्लीज गिव ऑल टॉपिक्स एंड सब टॉपिक्स टू मास्टर इन डीएसए. बस ये इतना बताना और ये अपने आप खुद ही तुम्हें बता देगा. उसके बाद ये सब सारे ये टॉपिक्स तुम्हें बता देगा. तो फिर अब तुम्हारे पास तरीका क्या रहेगा पढ़ने का कि भाई एक टॉपिक उठाना. ठीक है, अगर तुम्हारे पास टाइम अच्छा खासा है तो एक टॉपिक उठाना और ये टॉपिक उठा के इसको दे देना. ठीक है, कि ये टॉपिक मेरे को समझा दो. और ये टॉपिक जब ये समझा दे तो इससे क्वेश्चन भी मांग लेना साथ में ही, कि भाई ये जो टॉपिक तूने समझाया है इससे रिलेटेड लीड कोड और कोड फोर्सेस के मेरे को 3 4 क्वेश्चन दे दे प्रैक्टिस करने के लिए. वो क्वेश्चंस को ट्राई करना. ठीक है, और ट्राई ट्राई करने का मतलब कि एक क्वेश्चन मिला और उस पर टाइम देना. ठीक है, मतलब बहुत लोग ये करते हैं कि भाई आधे घंटे में समझ में नहीं आ रहा तो उसका सॉल्यूशन देख लेते हैं, लेकिन उससे फायदा क्या है मुझे ये बता दो. मतलब आप इस चीज के लिए अपने ब्रेन को ट्रेन कर रहे हो कि भाई तुमको कोई रियल वर्ल्ड प्रॉब्लम दी जाएगी, तो अगर उसका पहले से सॉल्यूशन प्रेजेंट होगा तो तुम सॉल्व कर पाओगे, वरना नहीं कर पाओगे. तो तुम्हें कोई हायर भी नहीं करे. तो ये वाली गलती कभी मत करना.
कि इसका सॉल्यूशन देखना, कम से कम 3 दिन ट्राई करो। 3 दिन। ठीक है, कम से कम 3 दिन ट्राई करो, 3 दिन के अंदर। ठीक है, जैसे आज मान लो कि ये क्वेश्चन मिला, अब तुमने आज जो टॉपिक पढ़ा था वही टॉपिक उसमें मे बी यूज हो रहा होगा। तो अगर वही टॉपिक यूज हो रहा है तो तुम पहले 1 घंटा सोचो, अगर 1 घंटे के अंदर नहीं सोच पा रहे तो भाई फिर दूसरे क्वेश्चन पे जंप कर जाओ, दूसरे क्वेश्चन के बारे में सोचो, और इस वाले सेम क्वेश्चन को अगले दिन सोचना वापस फिर से। अगर 2-3 दिन में, 2 दिन मैक्स टू मैक्स, एस तुम बिगिनियर हो अभी तो अगर 2 दिन में नहीं सोच पा रहे हो उसका सॉल्यूशन कि भाई क्या हो सकता है, सारी चीजें ट्राई करके देख लो जितनी तुम्हें आती है। अगर नहीं हो पा रहा तो 2 दिन बाद उसके हिंट देखना कि उसमें हिंट क्या क्या है, कैसे कैसे उसको सॉल्व किया जा सकता है। ठीक है, अगर वो हिंट से समझ में आ जाए तो कोड खुद लिखने का ट्राई करना, और कोड नहीं लिख पा रहे हो तो फिर जाके उसका कोड देख लेना। लेकिन बस एक चीज ध्यान रखना कि वो पहली बार और आखिरी बार ही हो जब तुम कोड उसको देख रहे हो। मतलब ये नहीं कि फिर से अगली बार वही क्वेश्चन करने आए तो फिर से तुम्हें वो सारी चीजें वापस देखनी पड़ रही हैं कि वो कैसे हो रही है। तो जितना टाइम लग सके एक क्वेश्चन पर टाइम लगा के उसमें जितनी डिटेल चीजें, सारी चीजें सीख डालो। और वो सब जब हो जाए, ठीक है, 2-3 महीने के अंदर जब सारा पूरा डीएसए कंप्लीट हो जाए, उसके बाद मेरे से बता देना, तो मैं तुम्हें फिर ये बता दूंगा कि कहाँ से प्रैक्टिस करनी है और क्या प्रैक्टिस करना है। क्योंकि कोई पर्टिकुलर शीट और ये सब करके कहीं अब सिलेक्शन होने वाला नहीं है, क्योंकि जो शीट है वो एक स्टैंडर्ड डीएसए पे बनी हुई है, और जो क्वेश्चन पूछे जाते हैं वो नॉन स्टैंडर्ड डीएसए पे पूछे जाते हैं। तो बेसिकली नॉन स्टैंडर्ड डीएसए वो होता है कि तुमने, या फिर तो वो कहीं तुम्हें कहीं प्लेटफॉर्म पे नहीं मिलने वाले, या फिर बहुत सारा मैथ घुस जाएगी उसके अंदर, या एकदम ही कुछ नया लग जाएगा, या वहीं क्रिएट हो जाएगा क्वेश्चन। तो वैसी चीजें तुम्हें कॉन्टेस्ट में ही मिल सकती हैं। तो हाँ, ये चीज ट्राई करना, अभी नहीं, अगर बिगिनियर हो तो अभी मत ट्राई करना। जल्दी से जल्दी डेटा स्ट्रक्चर्स खत्म करके फिर ट्राई करना कि कॉन्टेस्ट दूं। तो इससे हो जाएगा इम्प्रूवमेंट। यही तरीका है, और इसी से सारी चीजें इम्प्रूव हो जाती हैं। शेयर कर दूं? ओके, वेट। शेयर चैट। पब्लिक लिंक। वो भाई क्या है? यूट्यूब। हम्म। ये लो भाई, कर दिया शेयर। सो टोपो शॉट तो समझ गया। हाँ, हम यहाँ पे क्या समझ रहे थे? So we are understanding that okay, when I am on last point, what I will do, I will store it inside the stack, and then when I track back, uh, wait, I have to close it. Okay, so when I track back, I will see okay, three is visited. So as three is visited, I will store it inside the stack, and then jump up to okay, brother, and ये डीएसए के साथ एआईएमएल पढ़ूं या सिर्फ नहीं 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 भाई, पढ़ो भाई पढ़ो। जितनी चीजें पढ़ सकते हो उतनी चीजें पढ़ो, और एआईएमएल डीएसए अभी तो भाई बेस्ट है। यही दोनों करो, छोड़ना नहीं है कुछ भी। So when I am three, I will store it inside the stack, and then I will jump up to one. I will see okay, one is also visited, so I will store it. राज भाई क्या हाल चाल है? और भाई वंश भाई क्या चल रहा है? So when I am one, so I will store it inside the stack, and after that I will jump up to zero. So as zero is already visited, I will point it out and I will see that okay, now I am on zero. And now what I have to do is that I will see that is there any other way I have to go. So I will already see that okay, one is visited. Now I will left with two here. Two is the another part that I will follow from zero. So I will jump up to 2 because 2 is not visited. And as this is the last node, after that there is no node. What I will do, I will track back. Before tracking it back, what I will do, I will store the element. So 2 is already also stored in a stack. So after that, I will track back, and then what I will see that okay, I will left with 5 and 6, right? So I will left with 5 and 6. So what I will do is, so this is the same stack as I will not put 5 and 6 here. So I will create another one. कुछ नहीं, बस देख रहा हूँ आपको और क्लास को। अरे क्लास नहीं ले रहा। क्लास नहीं है वंश भाई। बेसिकली मैं क्या करता हूँ ना कि मैं जब पढ़ता हूँ कोई चीज, तो मेरे को ऐसा लगता है कि मेरे को कोई चीज जब ही आ सकती है जब मैं वो किसी को समझा पाऊँ। ठीक है। अगर मैं नहीं समझा पा रहा तो यानी वो चीज मुझे नहीं आती है। ठीक है, तो इसीलिए मैंने ये सब खोल रखा है कि भाई मैं खुद तो सीख ही लूं, और ये है कि अगर किसी को समझ में आ जाए इससे तो और बढ़िया है, मजा आ जाएगा और क्या। So I will see that okay, 5 and 6 is not visited. So I will jump up to 5. That what all nodes are not visited. So I will see okay, 5 is not visited, and I will see that okay, from 5 will I reach any other node? So I will see that okay, from 5 I will reach 4, and I will reach 6 also. So I will see that okay, 4 is already visited. So I will not follow this path, right? So this path is cancelled, and now I will left with this path only. So from 5, whatever. धन्यवाद अंश भाई, धन्यवाद. So when I'm on 5, I will see that okay, I can track this 6 path. Okay. So what I will do, I will jump up to 6, and I will see that okay, 6 is not visited. So I will mark it as okay, I already visited. I will create an array which tells me that if this is visited or not. Okay, fine. So what I will do when I on 6, I will see that okay, 3 is there. So 3 is visited. So it means that the 6 is the last node. So I will track back. So when I track back, what I will do, I will store that 6 here. And after that, I will reach out to 5, and then I will store the 5 also. And after moving from 5, I will see that okay, all nodes are visited, and in a stack, when I will clean the stack, or I will popped out all the element, what all elements are been printed. So 5 and 6 is there, and after that 2 is there, then 0, and then 1, and then 3, and then 4. So this is how we can perform a topo shot using DFS traversal. Now what I want is I want to perform a BFS traversal. So we have to analyze something. We have to analyze something. What we have to analyze? So what I will see that, okay, here 5 is printed first. Okay. And when I started from 0, 0 is printed first, and then 1, and then 3, and then 4. So this is how it's actually printed. So what I will see, or what I will think, that okay, so if I divide this array into two portions, that I know that these two are different, and this 5 are different. Let's suppose if we think it like that, okay, so because in one traversal, we can iterate over this portion, and I will print it, and after that I will check that what all nodes are left out. So I will see that okay, 5 and 6 is left out, so that after that I will print that 5 and 6. So one thing I observed that okay, so if we see the in degree, so what is in degree? That in degree is a point, or it is an arrow that is pointing towards a particular node. So if I see that what is the in order. Okay, so in order is okay. So in order, what is in order is? So I will see that okay, 0 has in order 0, because no array is pointing towards 0. Now after that, I will see that okay, 1 has in order 1, and 3 has in order 1, because 3 has in order 2. Okay, so 1 is pointing to 3, and 6 is also pointing to 3. Now I will see that what is the in order of 4. So 4 has in order 5, sorry, not in order, in degree. So 4 has in degree 3 and 5, because 3 is also pointing to 4, and 5 is also pointing to 4. 5 has 0 in degree, and then 6 has 1 in degree, and 2 has also 1 in degree. So, okay. So what I will see that okay, first in a first traversal, what we will actually do is that I will start it from some particular point. Fine. And what I will do is I know that where topological sort is used. So if I think about it, that where topological sort is used, I already understand from this example is that when we have to perform some operation in a sequential manner. Okay, that what is the most important thing? That I know that, okay, as I wants to open the FIFA.exe, first I have to open the main folder. Inside that there is a FIFA setup folder, and inside that there is a FIFA.exe, right? So it means that what I will see is that, okay, FIFA.exe is totally dependent on FIFA setup, and FIFA setup is totally dependent on main. And what I will see that, okay, main is not dependent on any other thing. It means that if we observe this pattern and if we see this, what I will see that, okay, when I traverse, first I will print this. Now after that, I will print whatever left. So I will left with 2. Now after that, I will see that, okay, I will left with this portion. So if we divide it into 3 parts, what we actually observe is that the node which has less in degree, that here we will see that, okay, 0 has no in degree, right? 0 has no in degree, means 0 in degree. So your buddy. So if I see that, okay, 0 0 has 0 in degree, so it will be printed first. Now after that, what I will see is, okay, so 1 has 1 in degree, because only 0 is pointing to 1. So I will print 1. After that, I will see, okay, 3 has 2 in degree and 4 has also 2 in degree. So it means that 3 is printed and then 4 is printed. Now this, after that, I will track back to 0, right? I will track back to 0. And now after that, what I will see is that, okay, from 0, is there any node that is left that I have to visit? So I will see that, okay, yeah, 2 is left out. So as 2 is left out, when I goes in this portion, and I will see that, okay, what is the less degree? Okay, what is the minimum degree in degree of a particular node? So I will see that, okay, if I travel in this way, I will see that, okay, 0 is there and 2 is there. But I already printed 0. So I will left with 2 only, and 2 has only 1 in degree because 0 is pointing to 2. So I will print 2. Now I will check that what all nodes are left out. So I will see that, okay, 5 and 6 is left out. So now I have to print 5 and 6. So how will I print? Will I print 6 first and then 5, or will I print 5 and then 6? So I will see that, okay, here 5 and 6 is printed. So what we observe is, okay, when I perform the traversal from 5 to 6, or in a on 5, what I will see that, okay, 5 has a 0 in degree, because no node is pointing to 5. And so as this has 0 in degree, it will be printed first. And after that, the node that has 1 in degree, which is 6, and that is not visited, because here 4 is already visited. So that's why I will not travel in this way. And I will travel onto that 6 point. Okay, so I will see that, okay, 6 has 1 degree, so that it will be printed after 6. So, yeah. So this is the observation, that what we actually observe here. That we observe that, okay, if I start from some particular node, what I will do is that, suppose I know that, suppose if I consider the adjacency list. So if I see there are adjacency list which is 0, and 0 is pointing to 1, 3, and 4, and 0 is also pointing to 2 here. So what I will do is I will see that, okay, 0 is there. So I will mark it as that, oh, okay, I already visited, or I will not store it inside a stack. What I will do is I will print that 0, or maybe whatever the thing I will do. Okay, so what I will see is, okay, 0 is there, and now I will check that what all nodes are connected with that particular 0. So I will see that, okay, with 0, I will see that, okay, 1 is connected and 2 is connected. So if I follow this one path, right? So all with 0, 1 is connected. So I will print that, okay, 1 is printed. Okay, now after that, I will see that how many nodes are connected with 1. So all node that is connected with 1 will be stored inside queue. and I will see that okay, 3 is there. So I will print 1 and then after that I will push 3. Okay, so something like that I will thinking. So I don't know this is the actual approach or not, but maybe we will reach up to some approach. Okay, so we have to do something. So we will analyze, okay, there is some node, and what we will do that if we will print that particular node, I will see that what all nodes are connected with that particular node. What I will do is I will store that particular node. So suppose if I store 1 and 2, because with 0, 1 and 2 is connected. So 1 is popped out. When 1 is popped out, I will push what? I will push 3 here. So I will push 3 here. Uh, so it will be pushed after 2, no? So no. So maybe this logic is wrong. So what is the actual logic and what is the Kahn's algorithm? So this is the Kahn's, not this is the Kahn's algorithm. We have to do something else. We know that we have to perform. Uh, we will think that okay, there is a traversal, and that traversal is according to the in degree, that the node which has less in degree will be printed first, and then the node with larger in degree will be printed one after the other. So that's why the 0 is printed and then 1 is printed, and after that 3 and 4 has same in degree, which is 2. The 3 and 4 is printed. Now I will left when I traverse over another point, I will see that okay, 0 has 0 in degree and 2 has 1 in degree. As 0 is already visited and already printed, I will left with 2 which has less in degree. So I will print 2 here. And then after that, I will see that how many nodes I will left with. I will see that okay, 5 and 6 I will left with, and 5 has 0 in degree. So that's why 5 is printed first and then 6 will be printed. Fine. So, okay. So what we will do is that first we have to calculate what is the in degree. That uh, I have to check that that what is the in degree of 0, what is the in degree of 1 and 3 and 4 and 5 and 6 and 2. And then after that I will perform something. Okay. So if I observe this code, I have to do something with this code. So what actually I will do here is that okay, I will create a vector array inside which I will store whatever the element I want to insert. That I have to insert 5, 6, 2, 0, 1, 3, 4 in this format. Now after that, I will see that, okay, I have to create an in degree array. Inside that, I will store that what is the in degree of a particular element. So 0 is in degree 0. And after that, what I will do is I will traverse over a 2D array, because I know that as I want to create a graph, I have to use either a adjacency list or either I have to use a adjacency matrix. So how will I know that what all are the in degrees of a particular element? Okay, so if I want to know the in degree of a particular element, I have to check, or I have to reach, suppose I want to, if there is a graph, suppose. So if there is a graph, I can store it in form of this. So 0, 1, and 2. Fine. 0, 1, and 2. And if I create a list, wait, if I create a list, a 0 is pointing to 1 and 2, and the 1 is pointing to 0 and 2, and 2 is pointing to 0 and 1. So if I want to know that what is the in degree, then I have to check on which node is pointing to 0. So I will see that okay, 1 is pointing to 0 and 2 is pointing to 0. So I will see that okay, so the in degree of 0 is here 2, right? So when I traverse over a vertices, what I will do, I will traverse over the vertices. Okay. And in a vertices, I will see that after that I will traverse over this, because I want to know that what all are the vertices linked with a particular element. So I will traverse over this. And now what I will do, I will create an in degree variable or in degree array. Inside that, what I will do. So what I will do, right? So suppose if I am standing on 0. Okay. Initially, I am on 0 point. So when I am 0 point, what I will do when I is 0 and j is 0. So let's understand this code and let's create an integrity. So I know that I have to create a integrity for three size graph in which only three elements are present. Okay, so how will I create it? So I know that there is a 0. So when I is 0 and j is 0, so it means that uh, this will point that okay I is 0 and this will point that okay j is 0. So when I is 0 and j is 0, what is the element? So element is 1, right? Now what I will do in degree, I will write adjacency list and okay. So what I will write? I will write that adj initially I is 0 and j is 0. What value will come? I will see that, okay, so the value is adj adjacency list 0 and okay, adjacency list 0 row and 0 column will point it to 1. So what I will do is, okay, if it is point to 1, so wait, if I create it, this is pointing towards it, or wait, I have to, oh, this is a directed, okay, so as I want to perform the Khan's algorithm, what I have to do, I have this is a topological sort. Now what I want, I know is that this will be performed in an acyclic directed graph. So acyclic directed graph means that I have to create some graph. Fine. So will I create this graph? What I've seen here is okay, 0 is there and 0 is pointing to what? 0 is pointing to 1 and 2. Now there is 1 is pointing to uh 3 only, and there is 2 which is pointing to no one. So I will leave that. Then there is 3, there is 4, there is 5, there is 6. I will create this. So I will see that okay, then there is 2 which is pointing to no one, and then there is 3 which is pointing to 4, and there is 4 which is pointing to no one. There is 5, there is 5 who is pointing to 4 and 6, and there is 6 who is pointing to 3. Okay, so 3 is pointing to 4 and 1 is pointing to 3. Okay, so if I create it, let's remove it. There is 1, 2, 3, 4, 5, and 6. So there's 6 here. So what I've seen here is okay. So when I is equals to 0, j is equals to 0, when I am on this point, I will see that okay, 1 is there and 1 is there, and what I will do in an in degree 1, I will mark it as 1. So the in degree of 1 is as 0 is pointing to 1, what I will do? I know that okay, 0 is pointing to 1 and 0 is also pointing to 2. So I will jump up to 1, and in degree what I will do is okay, mark the in degree of 1 to be a plus plus. It means that here I will see that okay, there is a plus plus. So what I will do that I can mark it as 1 degree. Now after that I will see that okay, 0 is also pointing to 2, so I will mark it as 1. Now I will see that okay, 1 is pointing to 3. So I will mark the 3 to be a 1. After that I will see that okay, 2 is pointing to no one, so leave it. I will see that okay, 3 is pointing to 4, so I will mark the 4 as in degree to be a 1. Then I will see that okay, 4 is pointing to 4 is pointing to no one. Okay, 4 is pointing to no one. Then I will see that okay, 5 is pointing to 4 also. So I will mark that 4 to be a 2. And then I will see that okay, it will pointing to 6 also. So okay, it will be 6. Sorry, 1. And then I will see that okay, 6 is pointing to 3 also. So I will mark that okay, this will be the 2. And now 5, no one is pointing 5 and no one is also pointing 0 here. So I will see that okay, so all zeros in degree, when I traverse, I will see that an element with 0 in degree will be printed first, and then after that, the increasing order of in degree will be printed. So fine. So I know that I can start it from 0. Okay, and I have to print all the vertices. So what I will do, I will create a queue here. I will create a queue here. And then after that, what I have seen here is, okay, queue is there, and I will run the loop v number of times. V number of times means V number of times means what? That okay, let's count what is the in degree. 1, 2, 3, 4, 5, 6, 7. So this is 7, in degree is 7. And I will see that okay, the nodes is also 7. So it means that the total in degree will be not more than the total number of nodes. Fine. So it means that I have to run the loop V number of times. So as I want to traverse or I want to print all the elements, because if I want to print all the elements in a sorted order, there is nowhere that same element will repeat multiple number of times or new element will be automatically generated. So if I want to sort some elements or if I want to print the sorting order of through graph, I know that only this nodes will come. So it means that if I already know that this all are the vertices, so this all the vertices will only print it. So it means that max to max, this loop will run vertex number of times. So I will use that for loop and I will start it from 0 and print it tell that how many vertices I have. Now what I will do is, okay, so there is if condition and this if condition will tell something that, okay, I will get 0. Okay, so I will see that, okay, 0 is there. And now I will see that what is the in degree of 0. So I will see that the okay, in degree of 0 will be 0. So as this is 0, not of 0 is 1. So not of 0 is 1. What does it mean? So I think so if in degree of I is not, so it means that till the point if I got 0. So first what I will do, I will see that what is the in degree of it. So I will see that, okay, in degree of 0 is 0. So what I will do is, what does this means? Not. Not means if this is not 0, I think so. I will see that what is the not of 0? Not of 0 is 1. So if some element has, huh, why I am gone confused because of this.
This is the starting point of Khan algorithm. Here exactly what it mean broken down. In degree I, the in degree of node is the number of directed edges pointing to its dependency term. In degree represent the number of prerequisite a task hai. If degree is 3, it means 3 other tasks must be completed before you do this task. Okay. If in degree is 0, it means task I has 0 dependency. You can do it right now. What does not in degree do? In C++, Java or JavaScript, the exclamation mark is not operator. When the in degree is 0, evaluate to true. When in degree is anything, okay, is anything greater than 0. In degree evaluate to false. So if in degree is just certain way of writing, why are you pushing it into the queue? Since task I has no prerequisite holding it back, it is ready to be proceed. We push it into the BFS queue so that algorithm can print or save it at a part of a final sorted order. So complete this task, which means we will soon look at all the next tasks that dependent on I and reduce its dependency count by 1. So okay. So according to the logic, what we do is okay, we will traverse over the vertex number of time, and when I found some vertex, after finding that vertex, I will see that okay, will I have to perform that task now, or will I pass it inside queue or not? So what I want is if some task is not dependent on other tasks, like
if first I have to open the main, after that I have to open the FIFA folder, and then after that I have to open the FIFA.exe. I know that FIFA.exe is dependent on opening the FIFA folder, and FIFA folder is dependent on main. So it means that first I have to check that what all are the elements or what all tasks that is not dependent on other. So I will see that okay, main is not dependent on other. So what I will do is I will tell the system, okay, I will store it inside the queue. Okay. And if all the operation that is running previously, if that completed, then please run that command. Okay, so that's why whatever the element or whatever the node that has in degree equals to 0, it means I have to execute it now. So what I will do is I will check that okay, if the particular element on which I will standing, if this particular node has in order to be a 0, sorry, in order, not in order, it's in degree, degree to be a 0, what I will do is I just push it inside the queue. So I will see that okay, 0 has not 0 has no dependency, so it will not dependent on any other node. So I have to perform whatever the task that is present inside 0 now. So I have to perform that task now. So what I will do, I will store it inside the queue. So I will see that okay, if there is some task that is equals to 0, or I have to write it equals to 0, because it will not depend on any other thing. So if this is 0, what I will do, I will push it inside the queue. After that, what I will do? After that, I will see that what all tasks are dependent on 0. So what I will do is, I will, as I was I will performing a BFS traversal. In BFS traversal, we will use a queue, right? So as we use a queue here, so what I will do is, till the queue is not getting empty, I will run a loop. And in a loop, what I will do, till the queue is not empty, I will perform some operation. So what operation I will perform? So I know that, okay, so if the degree is 0, I will push that, okay, 0 will be pushed inside. And now what I will do, I will popped out that 0. So I will popped out and I will store that I have to perform this operation immediately, because this has this operation 0 has no prerequisite or not dependent on any other. So what does it mean? That I have to perform this. So if I want to perform this, I will store it inside queue. And if I want to print it, what I will print? I will print that 0 first. So I will put out whatever the present in the queue, and then I will store it inside the answer variable. After that, what I will do, I will see that what all nodes are dependent on 1. After that, that will be performed. Right. So I will see that, okay, 0 is linked with 2 and 1. So I will iterate over an adjacency list. Okay. And I will see that, okay, with 0, 1 is there and 2 is there. Now, suppose there are two tasks, right? So if there is two tasks, first I have to open the main folder, and inside that there is another folder. I have to open that another folder. Suppose that folder name is FIFA folder, right? Now, main folder is executed, right? And because of main folder, the what we call this in degree of that FIFA folder is 1, because that main folder is pointing. So let's understand. So we will see that there is a main folder. Okay, and this main folder is linked with FIFA folder, right? So what we will see that, okay, main folder has no dependency. It means that I have to execute this task now. So what I will do is I will store it inside the queue and remove it from the queue, right? And this operation will be performed. Now I will jump up to this position. When I jump up to this position and this will be executed, what does it mean? It means that this will be removed. And if this will be removed, then what does it mean? It means that the in degree will be reduced. Previously, one node is pointing to FIFA or this node. it means that the in degree of this FIFA node is 1. And now if this will be executed and this will be removed, now currently this in degree will be 0. So what does it mean? That if I posted something inside queue and when I popped it out, I will check that what all nodes, like here 1 and 2, what all nodes are connected with that 0. So if this 1 and 2 is connected with 0, what I will do, I will either jump here or I will either jump on 2. So what I will do is that I will reduce the in degree of that particular node by 1. So what I will do is I will go inside the adjacency list and I will check that what is my current node. So I will store it inside there. And after storing that node, I will check that what all are the list that is connected with that node. So I will see that, okay, this all nodes are connected with that particular node. Okay. And in degree, what I will do, I will go inside in degree and reduce the in degree by 1. And if I reduce the in degree by 1, what happen is there is some nodes, suppose I will see that, okay, 0 is in degree 0. And now what happen is that q as and 0 is in degree 0, I will put it inside the queue. And when I put it out from the queue, queue is getting empty. And I will see that, okay, queue has in degree 0. So what I will do, I have to perform the task immediately. And all the task that is dependent on 0 will be performed next. So like here, after 0, 1 and 2 is performed. So what I will do is I will check that what all nodes are connected with 0. So I will see that, okay, 1 is connected with 0 and 2 is connected with 0. So I will point that, okay, 1 is now becomes 0 because that is the next task that I have to perform, and 2 is also becomes 0 because 0 is already executed. So I will see that, okay, 1 and 2 has in degree becomes 0. As the in degree will become 0, it means that there is no dependency. And now I have to perform that task immediately. So what I will do, I will store it inside the queue. Okay. And same as like that, this queue will be performed. And queue will be storing the element, removing the element, storing the element, removing the element. And after that, storing or removing, when the queue is getting empty, all the element will be stored inside the variable called answer. And I will return that answer. Okay, so this is how we actually have to perform this operation, that how we perform a topological sort using BFS traversal, and this will be called as the Kahn's algorithm. So this is Kahn's algorithm. Sorry, I don't learn the code. Maybe in future I will learn it, but I know the concept that what is the concept behind this Kahn's algorithm and that topological sort. So this is what it is. It take little bit of time because I study it today, so that's why I don't learn the code now, and maybe in future I will learn it. So I think so you will understand that what is this Kahn's algorithm and what is that topological sorting is. So hope so. Hmm. So let's revise it again. So if we perform a topological sort, what we actually do is, if we performing using the DFS traversal, what we will do, we will perform a DFS traversal and we pick one node. What I want is I want to print that particular node. For that, we will using the stack. So what I want is I will use the stack and I will also maintain a visited array that I already visited or not. Okay, so I will jump up to the last node and okay, so let's see here. So what I will do is, if you see that we already performed this topological sort on this position or this graph, what we actually do is, okay, I will start it from 0 and jump up to 3. And before track back, what I will do, if this is the last node, I will store all the element like 3 is stored, 2 is stored, 1 is stored, and then 0 is also stored. After storing, I will check that what elements are left, and then I again perform that same operation again. And I will see that, okay, 4 is not visited, I will mark it as visited. Then 5 is not visited, I will mark it as visited. I will see that okay, 0 is already visited. So I will start it from 5 and track back, and I will put that inside the stack. I will put the 5 and then I will put 4. And after that stack is filled, I will just pop out all the element and store it inside the answer variable or an array. And this is called the topological sorting. And this is how I actually printed. Now, what we do is this is the DFS traversal. And if we use the BFS traversal, okay, so for BFS traversal, what we know that we have to use Q, and that algorithm is called Kahn's algorithm. So we will perform a Kahn algorithm here. So in Kahn algorithm, what we actually do is, we know that if there is some task which is independent of any other task, like here 0 and 5 is not dependent on any other task. So what I want is I want to first execute that task, and then all the other tasks that is dependent on this will be performed. So first I have to check that what all tasks are independent. So for that, we observe that okay, uh, the task that is independent of any other task will have in degree is equals to 0 because no node is pointing towards that node. So I will see that okay, 0 and 5 is independent. So first 0 is executed, then 5 is executed, and whatever. Okay. So for that, what we observe is okay. So first we have to calculate that what is the in degree of each node. Okay, and then after noting it down that this is the in degree of this node, I will see that okay. So what I will do, what I will do is that I have to print that what all are the vertices that I have. So for it means that I have to run a loop vertex number of times. And now what I will check is that uh, if I traverse over an array, or if I traverse over a graph, what I will check is okay. So if I am standing on some particular node, will that node has in degree 0? If that node has in degree 0, it means that I have to perform that operation now. So as I want to perform this operation now, I will store it inside the queue. So okay, so after storing it inside the queue, I will run the queue till the queue is not getting empty. So till the queue is not getting empty, I will run that queue and I will check, okay, so 0 has in degree is equals to 0 because it means that I have to perform this operation. And when this operation is performed, I will store it inside the another variable called answer, which is a vector array. Okay. So I will store it inside the answer, and then what I will do, I will check that what all the operation that is dependent on 0. So I will see that okay, with 0, 1 and 2 is connected. So as 1 and 2 is connected and 0 is already executed, it means that it will be removed. And if this will be removed, so 1 and 2 is left, and now we will do, 1 and 2 has no dependency of 0 now. So what I will do is that I will decrease the in degree of 1 and 2. And if that in degree will become 0, so it means that I have to perform that operation now. So as I want to perform this operation now, I will store it inside the queue. So this is what I actually do, that I will get 0. So I will know that okay, 0 is in degree 0. So I will store it inside the answer, and I will check that what all nodes are connected with 0. So I will see that okay, with 0, 1 and 2 is connected. So I will go inside the in degree and reduce the in degree by 1, and I will check okay, if in degree will become 0, I will push it inside the queue so that next operation that is performed will be 1 and 2. And this is what it is, and that's it. Hope you understand. And this is what today. Thank you guys. Meet you soon. Meet you tomorrow. Good night. Bye bye. Tata. Take care.